I'm audible. I'm going to, I'm using ChatGPT for my study. This is a topic called in network and theorems. This is a topic called complete transparent response. I got an LinkedIn. This is my idea, and I'm uploading about stories, and you can find you can find some educational content related to electronics and communication. I am currently preparing for a telecom, so I am writing my notes here. You can study here. Continuation of OP amplifier and continuation of OP amplifier. Like this, I'm posting here. I have posted so many continuation of OP amplifier, JFET amplifiers, uh, DC equation like for a circuit. I have these equations here. Drain source to it and explaining junction field effect transistors. So many. Uh, and I'm partly an author of small stories. You can see some. I'm also doing some animation. You can see my this is reverse bias behavior and etc. So much content I am posting here. Uh, you can read it here from my LinkedIn. Ragun Shekhar Rama is my name, and this is my YouTube channel. This is Rani episode 2. I have uploaded 2 episodes. This is episode 1 and this is episode 2. I have uploaded 2 episodes. So don't forget to like, share, subscribe, and watch these episodes. I have my hobby to upload more and more episodes. Will come soon. Today we are going to study the complete transparent response behavior, complete response, natural response, response response. There are two major types: first order circuits RC and RL, second order circuit RLC. I have studied what is RC is a resistor connected in series with capacitor. Resistor connected in series with inductor. L means inductor. What is transient response? Imagine you having a switch. Before switching circuit is one condition. At t is equals to 0, switch changes means a switch on circuit suddenly changes. The circuit doesn't necessarily reaches its new steady state instant. Steady state means the DC behavior. The temporary behavior between the initial and final conditions is a transient response. Here, transient response is the behavior of initial and final conditions. Initial means at t equals to 0 plus final means at t equals to infinity. At t equals to 0 plus the capacitor doesn't takes the for t capacitor and inductor have some initial values. For t equals to 0 plus capacitor have some behavior and inductor has some different behavior. Like for capacitor, I don't remember exactly, but it is current max and the voltage equals to 0 for capacitor, and for inductor voltage equals to 0 and the current is max. Current is 0 and voltage is max. I'm thinking I forget that, but it is the main. The final condition they have it gets to 0, inductor gets to 0, voltage and current to max, something like that. Initial conditions we will see it later, but the in between the initial and final conditions, we tell that it is a transient response. The circuit reaches its steady state response, so complete response equals to transient response plus steady state response. After transient response, it gets a steady state means it doesn't changes again. It gets into one value, one state. Why does a capacitor cause a transient behavior? A capacitor source energy equals to half C V square energy definition of capacitor, and therefore VC equals 0 plus equals to VC equals to 0 minus. For example, if the capacity had V equals 0 minus 5 volts, and then immediately after switching V equals 0 plus is equals 5 volts. So this is before switching, this is after switching. The plus sign indicates switching on. After, it cannot suddenly jump from 0 volts or 10 volts. So it cannot change into suddenly. It cannot change its value suddenly. That's the state of initial condition. Why does an inductor cause a transient behavior? An inductor stores energy equal to half L square, and its current cannot change instantaneously. IL equals 0 plus equals to IL equals 0 minus. The current inductor initially carries 2 amperes, then after switching on it carries 2 amperes. It doesn't change very fastly. First order response for RC and RL circuits, the response normally has an exponential form. We see these derivations we see in charging equations, which you will find in my notes in the LinkedIn. RC equals to pi into pi equals to RC, RL equals to this is not phi, time constant. I don't know how to pronounce this. I say TC equals to L by R. I say TC equals to RC. For RC, TC equals to RC. For RL, TC equals to L by R. I call it time constant. The general first order response is x of t equals to x infinity plus x of 0. This is switching on state after switching on minus after for a while steady state. X of infinity represents u minus t by r TC time constant. So this is one of the most useful formulas to remember. Understand the formulas physically. Suppose the capacitor starts at Vc equals to 0 plus 0 volts, and eventually it's just Vc of infinity plus 10 volts, then Vc of t equals to 0 minus 10 e power minus t h time constant. X of 0 minus volt. Therefore, Vc of t equals to 10 into 1 minus 1 minus t power minus c by Tc. T equals to 0. You can get 0 at t equals to t tends to infinity. From This is the inductive. This is the capacitor definition. Equal to C divided VT is capacitor value 0. Then here V into 1 minus e power minus t by RC will come eventually. V equals to V 1 plus t power minus t by RC will become here. This is the charging equation for capacitor. So what is natural response and forced response? Natural response, suppose we remove the external source and leave the capacitor with stored energy. The capacitor discharges Vc of t equals to V square 0 e power minus t by RC. This is the natural response. Uh, Natural response here doesn't is this. When we remove the source, there's no forced response. The capacitor discharges means AC of 0 e power minus t by RC will be the natural response. Energy is already stored in the circuit. It is caused by energy already stored in the circuit. Forced response. Now suppose the source is continually forcing the circuit. For example, a 10 volt source charges a capacitor. The final 10 volts is determined by the external source. That's the forced response or zero state contribution. This is natural response. This is forced response. Forced response is caused by if you suddenly put the source here, we get a forced response from the source. That forced response is 10 volts 10 volts voltage. Then the complete response is both effects combined. Natural response plus forced response. Here we get this equation and substituting. This is forced final response. This is natural response. Then the final time constant. For a first order circuit, so this is the first order circuit equation means the first order circuit means RC and RL. For RC we get 1 pi, 1 TC, 2 TC, 3 TC and 4 TC and we get 92.2. At 5 TC we get 99.3. So we usually say 5 TC as fully settled for both the first for both 5 time constant rule means for both RC and RL we say 5 TC fully settled. But then what about second order circuit? Because it contains both L and C. We use words overdamped, two different real exponential terms, critically damped fast response without oscillation, underdamped oscillates without while gradually decreasing. So here overdamped means actually we'll cover this later. Two different real exponential terms because we get exponent e power minus t means for L and C we get two different e power minus t different exponential terms. Then critical dynamicity first fastest time response without oscillation. I don't know this. For the underdamped case, you get something like x of t equals to a power minus alpha t cos omega dt plus 5 where omega equals to root over omega naught square minus alpha. So the exact form depends on the circuit and whether you are analyzing voltage or current. So these equations are important. I think this is. I don't think this is important. Um, or now let's study what you should know for a standard second order system. I swear plus 2 alpha s plus omega naught square equals to 0, where alpha equals to damping factor, omega not equals to undamped natural frequency. The roots are s12 equals to minus alpha plus or minus root over alpha square minus omega naught square. The roots tells you the type of transient response. Overdamped when alpha's value is greater than omega naught, means damping factor is greater than undamped natural frequency. Then the two different real negatives as well as test tubes becomes zero, becomes less than zero. Response x of t equals to this value. No oscillation occurs here. For critically damped, alpha equals to means damping factor equals to undamped factor. I think undamped natural frequency. Repeated root s equals to minus alpha here as well. So here equations changes to here. There's no oscillation. It's boundary between over minus and under band. They look similar, but here S1 is used, S2 is used. Here S equals to minus alpha, so they both are same. So e power minus alpha t is used, but b here t used with 3. That's the difference between equations. Two different real negative roots. I think this is all mathematics. Here alpha is less than omega naught. Same as before, I think. Here greater, okay. Here alpha is less than omega naught. Complex conjugate roots. X equals to minus alpha plus minus j omega d, where omega d equals to root over omega naught square. Omega naught means undamped natural frequency, alpha means damping factor. Response equals to, so for undamped response is this e power minus alpha t cos omega dt beat sin omega dt. For the exam, prioritize characteristic equations, rules, or damped. Yes, we studied until here. We continue in the next part. I'm uploading this on YouTube. Subscribe, like, share. I will continue explaining like this. I try to use the my phone. My laptop camera is not working, so I'm using I direct ChatGPT to explain.